Okay, so we've been talking about how to convert from moles to mass and mass to moles, and how does this all relate? Well, we need to be able to sometimes, when we're dealing with gases, be able to convert from volume and moles and temperature and pressure and use all those things together. So the kinetic molecular theory and gas laws, what the gas laws are is they're just experimental observations that scientists have made about how gas behaves. And then the kinetic molecular theory helps to explain that. So what happens is we're going to talk about 4 different gas laws. Usually we're talking about what happens before and what happens after. We have 2 sets of conditions. Maybe we warmed up the room and so the temperature has gotten higher. So then what's going to happen to the pressure? We look at those types of relationships. This case here we're looking at 2 different pressures and different amounts. Okay, so if we know our pressure and the amount before, we can figure out one of these variables after. Okay, so both sides of the equation are talking about the same sample of gas. The 1 variables are before the change. The 2 variables are always after the change. So those will be how those relate. So the first law we're going to talk about is Avogadros Law. This relates our number of particles, or our moles, and then the volume. Okay. Temperature and pressure are going to be held constant, so the only thing that can change here is our number of molecules and the volume. The units must match. So if volume is in liters, it has to be in liters for both. So here the example is a sample of 0.5 moles of gas has a volume of 2.5 liters. What is the volume if the sample is increased to 0.55 moles? So that means we're adding more. We're adding more molecules. What's going to happen to the volume? Well, we're going to write down what we know. We know our first amount is 0.51 and our first volume is 2.5 liters. Always write these down with the numbers so you know where they're going to plug into your equation. The other thing we know here is that our second amount is going to be 0.55 moles, and we're trying to solve for our second volume. Now we can take these numbers and easily plug them into this equation. You can see right where they fit. Then you can either cross multiply 2.5 times 0.55 and divide it by 0.15, or if you want to rearrange the equation and multiply this to this side, you can do either way. It does not matter. So when we solve for this, we're going to end up with 9.2 liters. We look at our significant figures. There's 2 significant figures in all 3 numbers, so that's going to be our final answer. Does that make sense? Well, it should. If you look back here, if we started with 0.15 moles and it only took up 2.5 liters, if we're quadrupling that number of moles, we should get a much bigger volume, and we do.